So curves and surfaces. This is very much important while you are dealing with partial differential equations because it will give you an idea to visualize solutions while you are solving partial differential equations. What is a curve and a surface then? Let's begin with curve. We have this x-axis and y-axis called the plane, and we have something like this. Now the question is, what is this? In physical life, you can say that this is a rope or something like that. But in mathematical sense, this thing must be having some meaning. The easiest thing that you can do is represent it as a function of x. Most usually people write y as a function of x. Yes, that is fine. But what if we have another direction called z direction? We can still represent something like this in the 3 dimensions called the space. And in that case, the easiest way to represent this thing is by using the parametric form. The parametric form is basically represented as x is treated as a function of t. Similarly, y is treated as a function of another function of t, and z is represented as another function of t. Now all the 3 things are together merged and written in the coordinate form like this. Now that is all about a curve. Basically, the degree of freedom in curve is 1 because it is dependent on only one variable when seen in the parametric form. Now let's move to surface. Now we have already x, y and z axis. Let me tell you something. Suppose we have a cylinder. Think in your mind about the outer surface of the cylinder. Suppose I cut the cylinder like this into 2 parts and consider the upper part only. So I will get something like this. This thing is a surface. An example of surface. So how are we going to represent it? Let's have a zoomed picture of it. Okay. Now if you are going to find the representation of this, so it will be something like a function of x, y and z is equal to 0. Some people write is equal to constant, and that is fine. Now if you want to write the parametric form, then this is the parametric form, and it depends on 2 variables u and v. So the degree of freedom of a surface is 2. Now you are done with the representation of a surface. Suppose you are ready to find the normal at a point. It is similar to find a tangent at that point and find a line that is perpendicular to the tangent at that point. The normal can be found out by this p, q and -1. How we are going to find it? This will be the next task that we will be doing. And thanks for watching.